Good morning, America. How are ya? Monday Morning Rail. We'll be 500 miles before the day is gone. Hi, I'm Denny Yelsma, and I'm at the world-famous Jacksonville Terminal Railroad Museum. And today is Monday, and you know what we do on Monday? It's show and tell, and show and tell starts right now.
Okay. Hi, I'm Bernie Juncola, here at the famous Jacksonville Terminal Railroad Museum. I'm here to talk about the control and the different stop. Hi, I'm Bernie Juncola, here at the famous Jacksonville Terminal Railroad Museum. What I want to talk about today is how we control the railroad and talk about our signals and our crossing gates. At the Railroad Museum here, we use the Digitrax DCC for the control of the trains. We also have this railroad wired for DC, which is used sometimes, and I can talk about that a little bit later. But we're using Digitrax DCC. We have it divided into three different power districts. We have a DCS 210 under here that controls the railroad, and we have two DB 220s, one on this side and one on the other side of the railroad, which we'll talk about when we get over there. What we're using is the DCC Specialties PX, they are PSX1 circuit breakers on each of the power districts, so that we have them wired, we have them set a little bit lower than the trip point of the controllers of the boosters, so that they trip before the boosters would, in order to protect the boosters in our command station. So we also have the we also are using the Digitrax LNWI for wireless control of the trains here, and we have UR92s and 93s also for the Digitrax wireless throttles. Okay. So, as I was saying, we do have this railroad wired also for DC. Not used very often, but it's an option if we have that situation where we want to run a lot of DC locomotives on the railroad. Of course, we can use Digitrax 00 if there's only one DC locomotive on the railroad, DC train on the railroad, and that works actually very well. But if you look at the panels here, you'll see these rotary switches for each of these different sections in each power district, that we can switch to the various DC throttles if needed. But right now everything is set for DCC. As we get into the other things, I want to say that most of the locomotives here are wired for they have receivers in it for DCC, and most of them probably have sound in them also. We have one train that's one engine that's running right now, Atlantic Coastline. They are E8s or E7s, and what I wanted to get into to start to talk about was our block signals and then the crossing gates. The block signals are used for really train control, because there are several areas of the railroad where people can't see what's going on the other side because of our center island that really blocks the view. So the block signals really do work, and they are functional. If I start up 529 here, and we'll give it a little okay, and if we focus on the semaphore down there, went a little early. I have a timing circuit in there that gives it 10 seconds from when goes over the optical sensors until it changes the semaphore to red. But it is functional. The other end of the block now is good. And this will stop it. As I said, all the block signals and the crossing gates are controlled with optical detectors between the tracks. That was really the easiest way to do it. Using current sensors requires having the resistors on all the cars, and that was just too much. We're coming into Orange Park right now, and the crossing gates are active with the signals running. All of this, by the way, is controlled by Arduinos. There are several in there that have several different circuits running. And the gates, as you can see, after the train passes, the gates are raised. The signal drop as it goes past for crossing the Gertz Creek Bridge. And you've heard about the bridges in one of the earlier broadcasts where Bill has done most of the work. Or actually all the work on the bridges, I should say. He's our resident bridge expert. Alright, here at Folkston, we have actually a crossover track that will go into Waycross. We have signals that indicate the position, of course, of the crossover, and will the position of it will actually control the signals in Waycross when the trains come in the other direction. This first switch here controls a crossover if we need it. As you see, the block signals will change. The semaphore will change according to the position of the crossover, so that trains coming in the opposite direction will not, of course, derail. There is also if the crossover is used and going to Waycross, there's a switch here which takes the branch over to Waycross. And the semaphores, of course, change to show that a stop signal, I can't read it. Yeah. A stop signal here and a caution for going the other direction. Again, all of this is controlled by Arduinos. It was really a learning experience for me. I had a mentor that introduced me to Arduinos. It was something I hadn't really worked with before. I've been in the computer industry for 42 years, but I've not done programming. It was mostly hardware. I do understand how programs work, of course, but it's different when you actually have to sit down and write a program. The sketches for doing Arduino are relatively simple using C language, which is pretty straightforward, but again, understanding the process of setting variables and constants and writing loops and interrupts to then control servo motors, relays, LEDs. That was quite a learning experience for me. I started with some simple ones, basic crossovers with just flashing lights, and then using servos to control the crossing gates. As we got into the block signals, that was a little more difficult because in this case there were actually several signals, semaphores, or aspect lights to control as we took the train through the block to clear the other end to show a yellow signal when it was almost always through one of the blocks so that another train could follow. But again, it worked out okay. Just a lot of work. Now, as time goes on, I see things that I'd like to improve, of course, but time constraints and other things interfere with it. And when things go wrong, usually somebody in the club will let me know. I used to be greeted by, "Hey, by the way, Bern, this isn't working today," but it gets better. Now things are a lot more stable. And the maintenance is really minimal once it got done. Most of the problems end up being mechanical. A broken wire or something like that, as opposed to really something wrong with the program, because as most programmers know, the program never breaks. Okay, so the optical detection that's used, just to talk a little bit about that. Between the tracks, I started with something that, again, a fellow named, the name escapes me, Dr. Bunzel. They're differential detectors, so that they're actually two, one in the track and one alongside of it, so that it can react to lower light levels if we ever had the occasion to dim the lights or turn them out around here. And it worked pretty well, but it did complicate some things. The optical detectors obviously are always being checked to see if something is blocking them or not, but they work pretty well. Let me run through Folkston here. If you're familiar with Jacksonville, I think most of these areas will be recognizable to you. Of course, the layout is, as probably you've heard before, is in the set in the 50s and early 60s. So some of these things have changed quite a bit in this area. And I want to get it forward and watch the gates go down. I can't cross over because there's a train over there. Come through the Baldwin yard here, and then we will be approaching Main Street. Again, we have a clear signal, and the crossing will activate shortly, and there are lights. And after about 10 seconds, that clear signal will drop to red. I use 10 seconds because having additional detectors would just complicate things. There we go. And after we get through the second block, should see this, if everything is working okay, we should see this signal go to yellow. Wait till it gets past. Or maybe not today. Maybe I have to work on it. There we go. There's yellow. So now another train could approach from this direction, just knowing there's something ahead of it in the block. And then it'll go clear once we clear the other end. believe that's probably everything that I wanted to talk about here at the museum. I enjoy working here. I do more of this than running trains, but that's where my interest is. It was really fun learning to do this stuff, to get it working and get it functional, so that made it work. So thank you for listening, and we'll turn it back over to Denny.
Thank you, Bernie. We really appreciate that, and we really appreciate Bernie, because a club is only as good as its electronics when you're running trains. And people always ask, why do you have such smooth running trains? And the reason is because of Bernie Junko, and we really appreciate him, and thank you very much. And that's the way it is at the beautiful Jacksonville Terminal Railroad Museum in beautiful Jacksonville, Florida.